For section 5-4, chapter 5, section 4, we need to talk about the parameters for binomial distributions. Basically what this means, we need to talk about mean, variance, standard deviation, and the rule of thumb as it applies to the binomial probability distribution. What I'm going to do is I'm going to run through these slides. There's just 6 of them. There's an example in these slides that relates to McDonald's. And then we're going to jump over to the Excel spreadsheet, and we're going to use our binomial distribution function to work through the McDonald's example that's in our PowerPoint. And then we're going to go back and we're going to work through a baseball example. And hopefully between those two, it'll help you understand not only how to calculate mean, variance, and standard deviation, but probably more importantly, what we can say about a probability distribution and the possible outcomes once we know what the mean, variance, and standard deviation are. Okay, so let's begin with these slides coming out of section 4 of chapter 5, the parameters for the binomial distribution. What are we trying to do? Like I said, we're trying to find the mean, variance, and standard deviation, and then make sure that we know how to understand and interpret the results from these values. The range rule of thumb will make its appearance again, and we'll look at that here at the end of our slides. Here they are. Here are the equations for calculating the mean, variance, and standard deviation for a binomial distribution. They're not that complicated. I hope you can see that. To calculate the mean, you're simply going to multiply n times p, and the variance is n times p times q, and then standard deviation is the square root of that. And remember, n is the number of fixed trials, so if we're talking about going up to bat 5 times in a game, n would be 5. Or if we're talking about having 4 children, the probability, boys and girls, the number of fixed trials with having 4 children is 4. P is our probability of success, Q is our probability of failure in each one of those n trials. Okay, let's jump right in and get to that range rule of thumb that I talked about. You've seen this before, so this is a good thing that it's familiar. We start with the mean and we go up and down 2 standard deviations, and this gives us a range of what would be usual. Usual behavior would lie within these limits. Unusual behavior would lie outside of 2 standard deviations up and 2 standard deviations down. From our empirical rule, we know that this is roughly 95% of the outcomes. And so we're saying that anything that lies within the 95% is what we would refer to as a usual, or something that would be expected. Outside is unexpected. Okay, so here's an example. McDonald's has a 95% recognition rate. A special focus group consists of 12 randomly selected adults. For each group of 12, we can find the mean and standard deviation. Well, right here with 12 adults, and they have a 95% recognition rate, which means there's a 95% chance that each individual adult would recognize McDonald's. So we multiply 12 times 0.95 and we get 11.4. So that's the mean. It's the average out of a group of 12 that would know the McDonald's, would recognize McDonald's as a company or as a logo. The standard deviation can be the square root of n times p times q. 12 adults, probability of success, recognizing McDonald's is 0.95. Probability of failure would of course be 1 minus 0.95, or 5%. Multiply that together and you get this, 0.754983. If you round that up, it would just be 0.8. Now, going to that range rule of thumb, you can see that we start with the mean. Mean is 11.4. If we go up 2 standard deviations, that's 13 people. And if we go down 2 standard deviations from the mean, that's going to be 9.8 people. So if you're looking at a group of 12 people and all 12 would recognize the brand name of McDonald's, that's within what would be considered usual. So it's not unusual that if you pick 12 adults, you find that all 12 of them recognize the brand name McDonald's, because that's within this range. However, if you did pick 12 and either 9 or 8 or fewer than anything 9 or fewer recognize the brand name, well, that's outside of this range. Anything lower than 9.8, so 9, 8, 7, 6, that would be an unusual outcome. Okay? So the main thing, and we're going to be able to come back and reference these slides. You can see here that the mean is simply the product of NP. The variance is the product of NPQ. And then standard deviation is the square root of that. Rule of thumb, we've seen that before. Here's how it can be applied in a particular example with the McDonald's recognition. Okay, so once we calculated the mean and standard deviation, we know that 95% of the population, it would be 95% of usual behavior is going to lie within 2 standard deviations either side. So it would be fairly usual for 10, 11, or 12 adults out of a group of 12 to recognize the brand name McDonald's. But it would be unusual for 9 or fewer to recognize the brand name McDonald's. Okay? That is it in a nutshell. So let's shrink this down, jump over to Excel. Let me put this on our slide where we have the equations that we're going to be referencing. And here you go. This is the slide that has the 3 equations for mean, variance, and standard deviation. So I've just put as a reference here on top of this PowerPoint, of this Excel page, I've put as a reference the equation that we use for calculating probabilities in the binomial distribution. You see I put quotes around this. If I hadn't put quotes, it would have taken this as an actual function, as a command. But just to have it as a reference here at the top of the Excel spreadsheet, I've put it in quotes. Okay, let's go with the McDonald's example that we're talking about. N was 12, and so let me just look at the entire probability of events here. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. All right? Let's calculate the probability of each one of these cases. What's the probability that if you gather a group, randomly select a group of adults, and 0 out of 12 recognize the brand name McDonald's? Well, it has a 95% success rate. Okay, and we only want to know exactly the probability for this one outcome. We're not going to accumulate anything, so this is going to be false. This is going to be false for all of these. Okay? Yep. We kind of expected this to be super small. So again, let's, as we did in class, we want this to be a number. Let's see some more of it. Let's get it up here until we see. Oh, good grief. All right. That is really small. Okay? I'm going to change this function so that I don't have to put 0 in every time. I'm going to say use the value in the cell adjacent, just immediately adjacent there on the left. Okay, I'm going to get the same result in this one, but now that this is a reference to the value in A3, what I'm going to be able to do is click on this lower right hand corner and say, okay, I want to copy that function all the way down. And I want you to, let's click on like 4 here. What's going on here? It's calculating the binomial distribution probability with A7. Okay, so it's using the 4. And if we go down here to 10, it's calculating the binomial distribution probability with A13. Okay, so by, did I mess it up? Nope. Okay, good. Now, remember what it said over here? It said that the mean was 11.4 with standard deviation of 0.8. Okay, look at these probabilities. Of course, because it has such a high success rate of recognition, 95%, you can see that this is 1%, or 1.7%. Maybe we change these all to percents. We can go right up here and say, make these percents, and give me some more decimal places. I want to see more here. Yeah, we're just not going to see anything show up in these very, very low outcomes of 0, 1, 2, and 3. But when you get up here to 9 adults recognizing the McDonald's brand, that's just if you had a group of 12, it's not very likely that 9 of them, that just has a 1.73% probability. But when you get up to 10, that's almost 10% probability that 10 out of 12. There's about a 34% probability that 11 out of 12. And 54% of the probability that 12 out of 12 would recognize the McDonald's brand. So 11.4, you can see 11.4 is right in this mix, right in here in the middle of these highest probabilities. And the standard deviation is 0.8. If we move 2 standard deviations from 11.4, it puts us right here in the 10, 11, 12 range. Okay. The likelihood, or the probability that you would get together 12 adults and only 9 of them, that has a probability less than 5%. That's way outside of what we would consider usual. Okay. All right. So that gives us kind of a look at the distribution of probabilities that go along with the McDonald's example, where the mean is 11.4 and the standard deviation is 0.8. Okay, I want to do this for another case similar to what we did in class. Let's go with baseball, and we're going to look at a case where over the course of a game, a baseball player comes up to bat 5 times. Okay. And coming up to bat 5 times, let's say that his batting average is 295. Okay, BINOM, BIST. Okay, and we're going to look at the case of 0 hits, 1 hit, 2 hit, 3 hits, and so forth. So 0.295 is the probability. Oh, sorry, I skipped something, didn't I? Look right up here. Here's the number of successes, which is going to be 0. Number of trials, which is 5. The probability of success, 0.295. And no, I'm not going to accumulate this. This is just going to be singular events. Boom. So, there's a 17% chance that he comes up there and gets a goose egg every time. Okay. Now, because I created this with the reference to D3, if I go ahead and copy this down, putting my mouse on that lower right hand corner, there you go. Let's just check this. Yep, D6 is where I need to be. Alright, those are the probabilities of each individual outcome. If your probability of success, let's put that right up here, P equals 0.295, just so we have that as a reference. So the probability of success is 0.295, 29%, 29.5%. You can see that the highest probability comes right in here around one or two hits, and then it tapers off. If you have a batting average of .295, good luck getting 4 hits or 5 hits with 5 at-bats. Let's use these equations over here to calculate the mean and the variance is standard deviation, and then how do we want to do this? Upper end of usual and the low end of usual. That's going to be the rule of thumb. We're going to take the mean plus 2 standard deviations and the mean minus 2 standard deviations. Okay, for the mean, equals number of trials, 5 times probability of success, 0.295. Okay, there you go. That doesn't look... Oh, I left it as a percent. Let's get that out of there. We don't want this as a percent. We want this as just a plain old number. Okay? So 1.48. 1.48. So the mean is between 1 and 2. 1.48. That looks about right. Yeah? 36, 30, and it tapers off to 17 on one side, tapers off to 13 on the other. So the mean is right in here at 1.48. The variance is equal to n, which is 5 times 0.295. And if the probability of success is 0.295, then the probability of failure is going to be 0.705. Okay, and I wonder if this is still in percents. Nope, there you go. Variance is 1.03998. Let's get that down. Get that in alignment with what's right above. Okay, the variance is 1.48. This one is 1.04. The standard deviation is going to be equal to the square root of the variance. I'm just going to say whatever we have there in E11. Hit enter. And you have the standard deviation as 1.02. Take that down. That. And then we can use the rule of thumb, and we can start at our mean and go up 2 standard deviations. So I'm going to start here. So I'm going to say equals mean plus 2 times, oh, that is not going well. Let's delete out of that. What did I end up with? Okay. I have the mean plus 2 times standard deviation. Hit enter. Okay, so 1.48 plus, that would be 2.04. Yep. There's some rounding error in there. You can see that it's turned out to be 5.1. I bet if we bring this out a little bit, you'll see why it's 4.75. Okay. Yeah, there's just 1.9. So that's why it looked like 3.51. It didn't look like it added correctly when we told it to do twice the standard deviation. Okay. So 1.48 plus 2 times the standard deviation, and then we're going to take 1.48 minus 2 times the standard deviation, and oops, let that close it up, and that's negative. Okay, negative 0.56. And that would make sense that it's negative, because if you're at 1.48 and you subtract twice the standard deviation, that's going to be 2.04. That's larger than 1.48, so you get negative. So here's the deal. It would be usual for a batter with a batting average of .295 going up to bat 5 times in a game. It would be usual for them to have a batting average of 0. It would be usual for them to have a number of hits in a game of 0, 1, 2, or 3. 0, 1, 2, or 3 are within this range. 4 is outside of the range, so is 5. Okay? But 0, 1, 2, and 3 hits are within the range for the rule of thumb. Okay? So right in here is what we would expect on a normal day with a batter with a .295 batting average. This would be unusual because it's greater than 3.5. Alright? So there's the beauty of being able to calculate the mean standard deviation for a probability distribution, and then using the rule of thumb to be able to say, okay, what's in the regular, interval of what we would call normal outcome. Five or four hits in a game where they went up to bat 5 times, that would be highly unusual. All right, hope that helps, and I hope you get some good practice using this particular function in Excel. Have a good rest of your day.